All right, here we go. We got a quick video on chapter 2.5 quadratics. This time we're in the form of y equals a, x minus p, and x minus q, or a factor type form where one of the zeros is at x equal p and another zero is at x equal q. All right, let's take a look at an example of a regular function in factored form. We have y equals 2 times the quantity x plus 1 and x minus 3. And we're basically asked to graph the function. So what we do is we set our zeros equal to, our labels there equal to 0. And we have x plus 1, x plus 1 equals 0, so we get x is equal to negative 1. And then, come back in the screen here, x minus 3 equals 0, we get x equal 3. So we have a 0 at negative 1 and 3. Then what we do is, since we don't, from this point, we don't know where the axis of symmetry is, but we know that in each parabola it's equidistant. So from those zeros, it's going to be right in the middle. So what we do is just count through, and if it's equidistant, that must mean that our axis of symmetry for this particular equation is at x equal 1. So we do f of 1, that way we can help find the vertex. So we plug 1 back in here. 1 plus 1 is 2. We take 2 times 1 plus 1 is 2. And then if we put in 1 here, we get x, or 1 minus 3 is a negative 2. That gives us a negative 8. And so we get our vertex of the parabola there. And so yes, it does go through the x-axis. And if we wanted to just quantify that and make sure we did that right, we could FOIL this out and take x equals negative b over 2a, and we would find that once we took the opposite or negative of 2 divided by 2, we would get that x value of 1, confirming our thought in that. All right, next example is a little bit more theoretical. In fact, not as much numbers, but here's the question. It says, given the graph of the function, write the equation of the quadratic in y equals ax minus p times x minus q. So it gives us this graph, and we have negative 3 as one of our intercepts. It goes to the y-intercept of y equals 6, and then it comes back down to another x-intercept of 1. So I went ahead and labeled negative 3p and q as 1. So what we do is, since the x is negative 3 and 1, if we set that equal to 0 and resolve, we get x plus 3 and x minus 1. So we have our two intercepts listed there. Now, when x is 0, y is 6. Well, we have to figure out a way to solve for x, or for a, to write the full equation. So, in this case, if we know that the intercept is 0, at 0, its value of 6, then what we can do is set our x's equal to 0 and put y as our 6 and simply solve for that a value. So that's what we've done here, is 6 is equal to a times the quantity 0 plus 3 and 0 minus 1. We get 6 is equal to a, 3 times negative 1. And we find out that when we divide, we get a is equal to negative 2. So then we're able to write our final equation of y equals negative 2x plus 3 times the quantity x minus 1. All right, so that one is a really important one for us here to understand. From the graph, can we write an equation of the function? All right. Hope you enjoyed. Thanks a lot. Have a great time. We'll talk to you soon. That is quadratics in a times x minus p and times x minus q form. See you soon.